Hey everyone! Welcome back to Learn with Venky. Today, let's simplify the 4 laws of thermodynamics with easy examples so you'll never forget them. Let's jump right in. Zeroth Law, the law of thermal equilibrium. This law simply states that if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. If A and B are in thermal equilibrium, same temperature, and B and C are also in thermal equilibrium, then A and C must also be in thermal equilibrium. Example, a thermometer and your body, when they reach the same temperature, you get an accurate reading. First law of thermodynamics, law of energy conservation. This law states that energy cannot be created or destroyed, it can only be transferred or converted from one form to another. Example, the first law says energy is conserved. You get energy from the fuel, and some of that energy is used to move the car, while some is lost as heat. The total energy remains constant, but it changes forms. Second law of thermodynamics. The second law of thermodynamics is about the direction of energy flow and the inefficiency that comes with it. It essentially says that energy will always flow in a way that increases the disorder, entropy. There are 2 important statements that make up the second law. Kelvin-Planck statement. It is impossible to construct a heat engine that operates in a cyclic process and converts all the heat energy absorbed into work without any waste. Example. Think about your car engine again. Fuel, chemical energy, is burned in the engine, and part of that energy gets converted into useful work. The car moves. But not all of the energy can be converted into work. Some of it is lost as heat into the exhaust and engine parts. The Kelvin-Planck statement tells us that no engine can be 100% efficient. Some energy will always be wasted as heat. Clausius statement, entropy and heat flow. Heat cannot spontaneously flow from a colder body to a hotter body without external work being done. Example. Imagine you put a cold ice cube in a hot drink. The ice cube will absorb heat from the drink, it melts, and the drink cools down as it loses heat. Clausius's statement says that heat naturally flows from hotter to colder objects, like how heat from your hand warms a cold drink. If you wanted heat to flow the other way, from cold to hot, you'd need to do work, like using a refrigerator to move heat out of the fridge and into the room. Third law, absolute zero is unreachable. The third law states, as the temperature of a system approaches absolute 0 Kelvin, its entropy approaches a constant minimum. We can cool gases down to very low temperatures, but reaching absolute 0, minus 273.15 degrees Celsius, is impossible because all motion would stop. If you found this explanation useful, like, share, and subscribe to Learn with Venky for more easy-to-understand science and engineering videos. Hit the bell icon so you never miss an update. See you in the next video.